fertile fields, thriving crops, high quality and plentiful yields. The African land can provide all this and much more. Unfortunately though, this potential remains untapped. Currently, Africa's farmlands are severely degraded due to high temperature that accelerates chemical weathering, rampant deforestation, overgrazing, while humid areas suffer from high acidity and toxic levels of aluminium and iron.
Developed countries, in higher income countries, too much nutrient is being applied to land and getting into water supplies, causing pollution and eutrophication. Whereas in lower income countries, we have not enough nutrient being applied. So farmers are experiencing very poor yields, very poor nutrition, not be able to make farming profitable. But also this is leading to environmental problems.
To reverse this deterioration, science technology is applied, which takes into account the varied climates, soils, and crops that yield potential throughout the year.
New technology from lab to space is revolutionizing the way we provide soil and agronomy information that is relevant for informing developments and environmental decisions facing governments. At the ICRAF Soil Plant Spectral Diagnostics Laboratories, we are at the forefront in this revolution.
Our lab backstops several labs across the region, right from West Africa, Central Africa, down south, Southern Africa. We work with a couple of labs that run these instruments, ranging from the near-infrared spectrometers, the mid-infrared spectrometers. But our main focus for infrared spectrometer has been the high-throughput Tensor 27 and the alpha spectrometer.
This is the Infrared Spectroscopy Lab, and here we have the Tensor 27 high-throughput screening device, which helps us to analyze soils and plants using the mid-infrared range. We stack our samples in the robotic arm rack. They are scanned. This is the spectrum that we normally get. Further analyses are done to get the predictions of the sample.
We have harnessed technology that has been originally used in the pharmaceutical industry to develop rapid, low-cost, and simple ways of analyzing soils, plants, fertilizer, and organic resources using only light. This here is our portable X-ray fluorescence spectrometer. We are using it to analyze soils, plants, and fertilizer, elemental analysis. And within a measurement time of 10 minutes, you're able to get a spectral signature, giving you all the elements all the way from sodium to uranium in the periodic table.
The importance of this analysis, it reveals the nutritional content of soil samples. So if the soil is fertile, it will be indicated by the various elements that are within that very soil. If the soil is contaminated, which will be an indicator. If crops are planted within that very soil, they'll be contaminated, which will further be transferred down to human beings. So it is a versatile technique that easily maps an area to ascertain the nutritional content of our soil samples, of plant nutrients that we take, which most of them take in form of the elements.
The applications are product quality, knowing the nutritional value of the grains that farmers are producing is important. So we can boost the micronutrient content of grains and diets. And also screening for heavy metal pollution in plants and soils. With these technologies we can also test fertilizer quality. This is important because African countries are importing increasingly large quantities of fertilizer. They need to know that it's on spec, that it's what they're paying for. And in rural areas we have often problems of adulteration of fertilizers, so there's need for quality checks and controls. and we can do this quickly and cheaply with our new technology.
There's a lot of data that is being generated. The data is huge, it's very complex. When the data becomes available, we always want to make sure the data is in a format that we can interpret it. We have developed tools for this kind of interpretation. As I mentioned, the data is highly complex and we need to simplify it.
In Africa, human and laboratory capacity for diagnosing, surveying, and also managing soil nutrients is deficient and all three inadequate for the task. And we have been able to share our new science technology to build or develop capacity in about 17 laboratory networks in both Africa and abroad.
With full adoption and absorption of this into university curriculum, will have that great impact for future generation to adopt this and use these tools for their own national health surveillance system, for their own research.
Because now we can measure plant nutrients in plant tissues and products quickly and cheaply with our X-ray technologies, this is enabling us to map out plant nutrient constraints at large scales and actually map out responses to an uptake of plant nutrients and better calibrate our soil tests. This is providing whole new approaches to agronomy, what we call evidence-based agronomy. We can now pair soil and plant testing on multiple trials at many locations and get a much better understanding of what are the constraints.